Hello everyone, this is Q-Learning Survey Project Update number 6. This week's update continues the benchmark analysis direction from last week. Last week, we talked about the Atari benchmark coverage heatmap, which algorithms were evaluated on which game categories. This week, Hamna extended that idea with a protocol metadata table. The main question is no longer only was this algorithm evaluated, but also under what conditions was it evaluated. The core message is that Atari scores are not always directly comparable, even when they appear in the same table. Last update, the coverage heat map answered a structural question: which algorithms were evaluated? That is important because a missing score and a score of 0 mean different things. A score of 0 means the task was tested and the agent failed. A missing score means we do not have comparable evidence. This week's protocol table asks the next question: under what conditions were those evaluations run? This is where benchmark analysis becomes more subtle. Two algorithms might both report scores on the same Atari game, but if one uses 550 million frames and the other used 200 million frames, or if one used life loss termination while the other used game over termination, the comparison may not be fair. So the main point is, same game does not necessarily mean same experimental protocol. A benchmark score depends on more than the algorithm. It also depends on the evaluation protocol, how long the agent trained, how many seeds were used, whether sticky actions were enabled, whether no-op starts were used, how episodes were terminated, and how evaluation was performed. This may sound like small details, but they can strongly affect the final score. More training frames can give an algorithm more opportunity to improve. Too few seeds can hide uncertainty. Sticky actions can prevent agents from exploiting deterministic memorization. Life loss termination can make games easier by adding episodes earlier. Best checkpoint reporting can also inflate performance compared with fixed evaluation. So when we compare scores, we need to ask whether the conditions behind those scores are compatible. Hamna's protocol table focuses on four especially important metadata fields. First, sticky actions. Sticky actions add randomness by repeating the previous action with some probability. This helps break deterministic memorization in Atari. Without this information, it is hard to compare older and newer evaluations. Second, training frames. A method evaluated after 15 million frames and another evaluated after 200 million frames are not being compared under the same training budget. Third, seeds. Seed count matters because reinforcement learning results can have very high variance. If a paper does not report a number of seeds, then it is hard to assess reliability. And fourth, termination rule. Some older papers use life loss termination, where losing a life ends the episode. Others use game over termination, which is more realistic. This changes the task difficulty. These are not just formatting details, they affect whether benchmark comparisons are methodologically valid. Now, the table already reveals an important pattern. DQN-era papers such as Nature DQN, Double DQN, Dueling DQN, and Prioritized Experience Replay often use 15 million frames, no sticky actions, and life loss termination. Later distributional-era papers such as C51, Cura DQN, IQN, and FQF often use 200 million frames and game over termination, so seed counts are often missing. This means the Atari table may place these algorithms side by side, but their reported scores were produced under different experimental conditions. So a direct leaderboard interpretation can be misleading. The table is useful, but we need protocol metadata to explain what kinds of comparisons it can and cannot support. Now, for example, the rainbow example makes this issue very concrete. In the original rainbow evaluation, the reported median human normalized score was 4.2%, the mean was 24.1%, and two games were superhuman. But when rainbow was re-evaluated under a stricter protocol, the median dropped to 2.6%, the mean dropped to 17%, and the number of superhuman games dropped from 2 to 1. The algorithm did not change, but the evaluation condition changed. Stick action was enabled, the life source signal was ignored, the full action set was used, and the evaluation used a fixed 30-minute window instead of relying on a more inflated reporting setup. The lesson is that protocol differences can change the conclusion, not just the number. Now we have two benchmark artifacts that work together. The coverage heatmap answers what was evaluated. It tells us which algorithm and game categories have reported results and where the table has missing entries. The protocol metadata table answers how was it evaluated. It tells us whether this reported result came from compatible evaluation conditions. This combination is powerful because it prevents us from treating the benchmark table as a simple leaderboard. Instead, it becomes an evidence map. It tells readers not only which methods have scores, but also how trustworthy or comparable those score comparisons are. This is exactly the kind of deeper benchmark synthesis that can strengthen the revised survey. Now, this gives us a clear path into Section 5a of the manuscript. Section 5a can include a coverage and comparability subsection. The first part can present a heat map and explain what was tested. The second part can present the protocol metadata table and explain which comparisons are methodologically compatible. Then we can add a short discussion explaining why direct ranking across papers is limited. This does not require a very long section. The key is to make the benchmark caveat visible and structured. And the survey should not only report Atari scores, it should explain which comparisons are supported, which are uncertain, and which require protocol caveats. Finally, the next step is to complete the protocol metadata table for all 21 algorithms in the benchmark heatmap. For each algorithm, we should log sticky actions, training frames, seeds, and termination rules. It is also important to explicitly flag not stated entries. A missing protocol detail is itself a finding because it tells us the comparison cannot be fully audited. One open question is whether we should add compatibility flags such as compatible, partial, or incompatible. That could make the table easier to read, but it may also introduce too much judgment. Later, we can extend this same approach beyond Atari to benchmarks such as Mujoko, Proction, Bench, SMAC, and language-oriented benchmarks. The main message this week is that the benchmark track is now asking a deeper question, not just who scored higher, but whether the scores should be compared at all. That's all for this week. Thank you everyone for listening.